Welcome to my channel. The session today is 3-point starter. The contents what we are going to discuss is about the necessity of the starter, significance of the back EMF, and the construction of the starter. We will see the circuit diagram of it and the working principle and some of the importance of the 3-point starter. What is the necessity of the starter actually? The starter we will use to limit the high starting current and to prevent motor from under voltage, no voltage and over voltage. So because of that, the starter is necessary. Significance of back EMF. The back EMF EB plays a crucial role in governing the operation of the motor. So the back EMF EB is developed as motor armature starts to rotate in presence of magnetic field. So initially the back EMF is 0. For motors, V is equals to EB plus IARA. Since initially EB is 0, IA is equals to V by RA. So according to this formula, as EB is 0, IA is equals to, that is armature current is equals to V by RA. So by the above equation, we can say that the starting current is dangerously high because we know that in motors, armature resistance is very small. So here EB is 0. So the starting current, that is armature current, is very high. So here in motors, EB is very significant. That is why the back EMF is playing a crucial role in governing the operation of the motors. Once the motor starts its speed, the EB keep on increases. So as EB is increasing, according to the formula, V is equals to EB plus IARA, the armature current will reduce because at that time the formula will be, armature current formula will be IA is equals to V minus EB divided by RA. So here we are getting the EB part as the speed is increasing. So as EB is increases, IA decreases. That is why the starter will be used only in the starting time of the motor. As the motor picks up its speed, the starter is not necessary. Means in running condition, the starter is not necessary. So the construction of the 3-point starter. It consists of a variable resistance which is having number of contact points, that is 1, 2, 3, 4, 5. 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, which is called as studs. There are 3 terminals in 3-point starter. That is why it is called as 3-point. That is L, line terminal, A, armature terminal, F, field terminal. L line terminal connected to positive supply and A armature terminal connected to armature winding and F field terminal connected to field winding. The point L is further connected to the electromagnet called OLR, which is overload release. And the second point of OLR is connected to the starter handle. The handle is free to move on other side towards run against the force of a spring A. A soft piece, iron piece, is attached to the handle. A parallel path is derived from stud 1 to no volt coil and the other end the no volt coil is connected to F terminal. The overload release and no volt coil are both protective devices. We will see in the diagram. So this is a 3-point starter circuit diagram. So these are the resistors and these are the points 1, 2, 3, 4, 5 called as studs. Here this is a no volt coil. So here if you see the 3 points, that is L, F and A. These 3-point type of starters mostly used in, it is used for shunt type of motors. So this is a overload release coil. So if you observe here, the field winding, first the positive is connected to L and from L to the overload coil. That is connected here it to the handle which is going to contact to the studs. From point 1, it is connected to here at no volt coil. And the another end of no volt coil is connected to the field winding F. And parallelly, the no volt coil 2 ends are at a triangular piece if you observe here. And the last stud is connected to the armature, one of the point, and the armature other point and the field other points both are connected to the negative. So
So here, so here if we observe, the handle is, here the handle is in off position, and when power is switched on to the motor, the handle is slowly moved to stud 1 against the spring force, and the following will happen. The field winding will get supply via parallel path provided through stud 1 and NVC. So we will see the diagram once again. Okay, here, see these are the studs. This is an off position. This is a spring. Okay. The field winding will get supply via parallel path provided through stud 1 and NVC and NVC. Like this it will get. So from here to here, like this. So entire starting resistance is in series with the armature and limits the starting current. Here all these resistance are in series with the armature winding. As the handle moves further to stud 2, 3, 4, 5 and finally run position, it bypasses the starting resistance and the motor rotates at a normal speed. So when the handle is moved to 1, 2, 3, 4, 5 till run. Run is the final running position, and this all starting resistance will cut off and it will run in the normal position. At that time, there is not necessary of the starter. So we are not using at that time the resistance. That is a starting resistance. NBC coil holds the starter in run position. So it is called hold on the coil. Here, if you observe, this is an no volt coil. When this handle reaches to at position, run position, this knob, this is will get energized and will hold the soft iron piece when it reach to the run position. So this will be holded. The function of no volt coil. See, here we'll see again clearly. The field winding is supplied through NVC and field current makes it an electromagnet. When the handle is at the run position, the soft iron piece on the handle gets attracted by the magnetic force produced by NVC. As the current is moving like this through the coil, this NVC coil will get energized and the soft iron piece will be attracted by the electromagnet. This coil will act as an electromagnet. So whenever there is a supply failure, field supply is broken. The NVC loses its magnetism and unable to hold the handle. The spring action brings back to the handle to the off position. See, whenever the supply is low or else the power off in the both condition, either in a low voltage condition or power off condition, this NVC will de-energize because the supply will come from here to the line like this. When it reaches to run position like this, it will come. Okay. So what happens at the low voltage and no voltage? At that time, this no volt coil will de-energize. So that will release the soft iron piece and the handle will be pulled back by the spring. So NVC performs the similar action during low voltage condition and save the device. Hence, as this NVC acting as a protecting device for the machine. So this is the starter is used for the starting purpose and also it is acting as a protective device. Function of overload release. Yes, here we have an overload release. So we will see the function of this coil now. The motor current is supplied through OLR coil, that is overload relay coil, which makes it an electromagnet. So when the current is moving like this will energize. Below the OLR coil, there is an arm which is fixed at the fulcrum or laying horizontal. Here. At the end of the arm, a small triangular piece is lifted, which is in the proximity of two ends of the shorting cable on NVC. Here. It is so designed that till the full load current, OLR coil, magnetism and gravitational force are balanced and OLR is enabled to lift the lever. Okay. So there will be a rated current for any motor. So till the rated current of the motor, this is not pulled, this lever is not pulled. It is so designed that this OLR, this coil only magnetize when the current through this will cross the rated current. That means overload current. When it, if, that is what they said, that it is so designed that till the full load current, OLR coil magnetism and gravitational force are balanced, and OLR is unable to lift the lever. Whenever the motor draws high current, the magnetism of the OLR coils pulls the arm, and triangular piece of the arm shorts both points on NBC. So this will short. So what happens? We'll see. Once this is shorted, see, this is pulled up. Once the current is, high current is flowing through the line, this is pulled up and this is going to short like this. We see then as that both are shorted, so there will not flow any current from NVC. So directly the current will flow through the field. So NVC coil loses its magnetism because the current is not flowing through the NVC once the triangular piece is short circuited, and leaves the handle. So when there is no current flowing in this NVC, what happens? This is demagnetizes and it will leave the soft iron coil. So the handle will be released. Hence, again here, this is also acting as an protective device. Means even in high currents also, acting as a protective device. NVC coil loses its magnetism and leaves the handle. The handle then retracts back to off position because of spring action. Then the motor will stop. Yes. Okay. Hope in the both the cases you understood. Again, once again, I will tell this NVC and OLR. Yes, here, say the handle is moved to the start 2. Once the handle is moved to the start 2 position, the current will flow from R1 like this and no volt coil to the field. And again, another current, that is armature current, will flow like this through the armature. So as this handle is moving 2, 3, 4, 5, once it reaches to the run position, at that time the field current will flow in this path, and the NOC coil will get energized, and anyhow this soft iron piece will come near and this will attract the soft iron piece. So at this position, this is attracted and the current will flow like this, that is armature current. So here we observe there is no any external resistance added at position 1 to the armature. Yes, if the case 1, either there is a low voltage or there is a no voltage. At that position, what happens? This NBC coil will Example, say here some cut or else that is no power. When there is no power, the current will not flow in this. So this will de-energize. So hence it will release the handle. So it is protected. Okay. So at that time, this is protecting. Okay. Next, at overload time. See, in the overload time, what happens? The current will flow like this from the line to the OLR, and if it is at run position, say it is at run position, then it will go through the handle and like this it will go. So the OLR is designed in a such a way this will act as a magnet only when the very high current means after the rated current it will act as a magnet and it will pull this lever up. Once this lever is pulled up, the triangular piece will attack will short this. So what happening means at this time when these two ends are shorted, so the line is directly connected to the field and disconnecting the NOC coil. So once the NOC coil is disconnected, again this will de-energize and it will release the handle. So it will go to the off position. So in the both the conditions, OLR and also NVC are protecting the motor. So this is about the 3-point starter. So there are some drawbacks in the 3-point starter. To increase the speed of the motor, the field resistance can be increased. This will reduce the amount of the current through shunt field because if we observe here, when it is in run position, all this resistance is added to the field, which will reduce the field current. As NBC is connected in series with the shunt field, the small current will reduce the strength of the electromagnet. So the electromagnet strength will also reduce. This holding magnet may release the arm of the handle during normal operation of the motor and disconnect it from the supply. This is very rare chance. This can be overcome by 4-point starter with NVC is connected in parallel to the field. So the what are the disadvantages in the 3-point starter which is overcome by using the 4-point starter. So hope you people understood about the 3-point starter. Thank you.